So when it is calculated more than once in a year, it is called as effective rate of interest. So the compound interest is given by the formula CI, which is also equal to A minus P. She is retired at 58 and the amount she will get is 70. So therefore the time period N is equal to 12 years. Whenever we calculate compound interest more than once in a year, we call it as effective rate of interest. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to study about the compound interest. So the compound interest is given by the formula CI, which is also equal to A minus P. Here A is an amount and P is the amount invested or borrowed. So now it's the principal. So here the amount is calculated differently in case of compound interest. So therefore it has a formula A is equal to P into 1 plus I whole power n. So here I is nothing but R, which is called as the rate of interest. But here I is always in the decimal form. Usually when we are writing the simple interest formula, R 12% means we'll take R is equal to 12. But in case of compound interest, if the interest value is 12%, we'll write only the decimal form. So we'll consider it in the form of 0.12. And next we have the same formula can be used to calculate the interest, which is given by antilog of log A minus log P divided by N minus N. Similarly, we can also calculate the time period. So here the time period is not given by T, it is given by N. So therefore, N can also be calculated using the same formula. That is, N can be calculated as N is equal to log A minus log P whole divided by log of 1 plus I. So this is the formula where we can use to calculate the time period using compound interest formula. So now let us take the problems related to compound interest. So when Geeta retired at 58, she deposited 1 lakh in the bank, which pays 18% per annum compound interest. How much amount will she receive when she is 70? So she is retired at 58 and the amount she will get is 70. So therefore the time period N is equal to 12 years. And the next is the principal is given, so that is 1 lakh. The next is interest is given 18% and it is calculated as I. 18% is nothing but 0.18. So the formula for an amount is P into 1 plus I whole to the power N. So that is 1 lakh 1 plus 0.18 whole to the power 12. So 1 lakh into 1.18 whole to the power 12. So always use the calculator for better verification. Here you need to multiply 1.18 12 times since the power is 12 and then you multiply the result by 1 lakh. So then the final value will be 728,759.26. So this will be the value. So this is the amount she received when she was 70. Next question. In how many years a sum of 2000 becomes 2,205 at the rate of 5% per annum compound interest? So we know the formula amount is equal to principal into 1 plus I whole to the power N. So here we need to calculate N. So we don't know the value of N. Amount is given, so that is 2,205. Principal is given, so that is 2,000. And 1 plus rate of interest is 5%, so it is 0.05 whole to the power N. So here when you are calculating the index value, it is always better to apply log because log helps in calculating the value which is in the index form. So therefore if we apply log here this becomes log 2205. Now since this is a product, this is X, this is Y, so I can write this as log 2000 into log 1 plus 0.05 whole to the power N. We also know that whenever we have a log with an exponential function, for example, m power n, then I can write it as n log m. And whenever there is a product here, so we always use plus in between the two numbers. For example, log m into n can be written as log m plus log n from the properties of logarithms. So here I am applying log for the easiest simplification. So now this can be written as log of 2205 minus log of 2000. Here we will get n into log of 1 plus 0.05. Now since I need n, I can write this as log of 2205 minus log 2000 whole divided by log of 1 plus 0.05. See, this is same as the equation which I have written earlier, log A minus log P divided by log of 1 plus I. We can also use the direct formula for n to calculate the values. Now using the logarithm table, we will find the values here. So now the value of log 2205 is 3.3434. Next, log 2000 is 3.3010 whole divided by log 1.05, 0.0211. So after simplification, the value of n is equal to or approximately equal to 2 years. So therefore, here the time period is 2 years. That means it takes 2 years for the sum 2000 to become 2205 when compounded annually. Next question. Calculate the amount received after 15 months if 8,500 is invested at 8% per annum compound interest. So it's a direct question. We have a time period, amount and rate of interest. We need to calculate the compound interest. First, let us calculate the amount. So it's a direct question where we have the time period, principal as well as the rate of interest and compound interest. We are calculating amount now. So A is equal to P into 1 plus I whole to the power n. Now amount is calculated with the principal 8,500, 1 plus rate of interest is 8%, which is 0.08. Now time is given as 15 months. So we have to convert this into years. So 15 months means when you divide by 12, that is equal to 1.25 years. So now here we have A is equal to 8,500, 1 plus 0.08 whole to the power 1.2 here. So here 15 by 12 can be written as 1.25. But again here our index is in the form of a decimal. So here also we can apply log to remove the equation. 1.25 as a whole number. So we can write this as log A, and here we can use it as log 8,500 plus 1.25 into log of, so 1 plus 0.08 becomes 1.08. So here we can calculate log 8,500, 1.25 log 1.08. So simplifying this, because this is a product, log m plus log n, and this is in the m power n, so I can write it as n log m. So simplifying this using logarithmic tables, so we will get the value as 9538.3357. So this is the amount we'll get with the help of log. Next question. At what rate percent compound interest a sum of 2,550 will amount to 2,952 in 3 years? So we are calculating the rate of interest. So we have learned the formula for rate of interest, that is I is equal to anti-log of log A minus log P divided by n minus 1. So we can directly substitute in the formula. So I is equal to anti-log of log A minus log P divided by n minus 1. So therefore this is equal to anti-log of, so what is the value of an amount? So amount is 2952 and principal is 2550. So number of years given is 3 minus 1. So using the log value here and calculating with the anti-log, we will get 0.05 as the answer. So 0.05 is nothing but 5%. So that means we need to substitute the log value of 2952 and subtract it with log value of 2520. So divide it by 3, then take the anti-log of these value and subtract by minus 1. So using log and anti-log tables, we need to find their values. So the final value will be equal to approximately 0.05, which can be expressed in percentage as 5%. So therefore, the rate of interest for this problem is 5%. Next one, we have the nominal rate and effective rate of interest. So what is this nominal rate and effective rate of interest? So under the problems we have done earlier, we have always considered the compound interest annually. But we can also calculate the compound interest in a year more than once. That is annually, semi-annually, quarterly, or once in a 2 months, once in a 1 month, depending upon the period. So here, whenever we calculate compound interest more than once in a year, we call it as effective rate of interest. So then what is the nominal rate? The annual compound interest rate is called the nominal rate. Whenever the compound interest is calculated annually, then it is called as nominal rate, whereas it is calculated more than once, that is twice, half yearly, 4 times quarterly, or more during a year, like every month also we can calculate the compound interest, then the interest is called as effective rate of interest. So when it is calculated more than once in a year, it is called as effective rate of interest. So thus, effective rate of interest always have the greater value than the nominal rate of interest. Now we'll take up the problems related to effective rate of interest. The formula to calculate the effective rate of interest is given by R is equal to 1 plus I by Q minus 1. So here R is equal to interest in the decimal form, so which is given in the decimal form, and effective rate of interest is R and Q is the number of times interest is. And here, thus effective rate of interest will always have the greater value than the nominal rate of interest. So that is, the compound interest calculated annually will be always less than the compound interest calculated in a year more than once. And the formula to find out effective rate of interest is given by R is equal to 1 plus I divided by Q whole to the power Q minus 1. So here Q is the effective rate of interest and I is the rate of interest, compound interest they have given. So this will be the effective rate of interest calculated semi-annually, quarterly or monthly, etc. Now let us take the problems on effective rate of interest. Find the effective rate of interest at 6% computed once in a 3 months. So when we say once in a 3 months, in a year it is calculated 4 times. And the rate of interest is 6%. So which means here I is equal to 0.06 and Q is equal to 4. So 3 months means in a year we need to calculate 4 times. So therefore the effective rate of interest is given by 1 plus I divided by Q whole to the power Q minus 1. So that is 1 plus 0.06 divided by 4 whole to the power 4 minus 1. So evaluating this, we'll get 1.0613 minus 1, which can be written as 0.0613. So this is the value of R. If you want to convert this into percentage, then it will be 6.13%. Now using this effective rate of interest, we need to calculate the amount whenever it is required. Next problem, if the nominal rate is 13%, and frequency of computing interest is once in 4 months, find the effective rate of interest. So nominal rate is nothing but your I, which is 13%, which can be written as 0.13, and frequency of computing interest in a year is nothing but your Q. So here once in a 4 months means in a year it is 3. So therefore Q is equal to 3. So thus effective rate of interest is 1 plus I by Q whole to the power Q minus 1. So this is equal to 1 plus I is 0.13, Q is 3 whole to the power 3 minus 1. So evaluating this, we'll get 1.1346 minus 1. So next subtracting we'll get 0.1346. So this is the effective rate of interest, which can also be written as 13.46%. Next question. Rupees 16,000 invested at 10% per annum, compounded semi-annually, amounts to 18,522. Find the time period of investment. So before that, here it is not compounded annually, it is semi-annually. That means once in a 6 months. So therefore, here we need to calculate the effective rate first. So for that, here I is given. So which is 10%, which is 0.1. And next time period is given semi-annually. So twice Q is equal to 2. R is equal to 1 plus 0.1 divided by 2 whole to the power 2 minus 1. So evaluating this, we'll get R is equal to 0.1025 or 10.25%. Remember here we need to calculate the time period. To calculate the time period, we know the formula A is equal to P into 1 plus I whole to the power N. So here I is replaced by R because it's the new rate of interest. So therefore this is principal is 1 plus R whole to the power N. N is the time period which we don't know. So to calculate N, we have learnt the formula N is equal to log A minus log P whole divided by log of 1 plus I. Here it becomes 1 plus R. Now what is the amount we have? 18,522. So which is log of 18,522. Next we have log P. The principal is 16,000. So it is log 16,000 whole divided by R is 0.1025 because we need to take the decimal form when you are calculating the compound interest problem. So therefore 1 plus R becomes log of 1.1025. So solving this using the logarithmic tables, so we will get N value as 1.501. So which can be approximately equal to 1.5 years. So using log tables, you need to find the value, their difference and divide by them. So you will get the decimal as 1.501, which can be approximately taken as 1.5 years. Next question. Find compound interest on 8,000 for 8 years at 16% per annum if interest rate is calculated quarterly. So here it is calculated quarterly. So therefore there is a effective rate of interest. So hence quarterly means the period is thrice year and interest is 0.16. So therefore the effective rate is 1 plus 0.16 divided by 3 whole to the power 3 minus 1. So R is equal to 1.1698 minus 1. R is equal to 0.1698 or 16.98%. Now we need to calculate the amount here as well as the compound interest. So therefore first let us calculate the amount, which is P into 1 plus R. Here instead of I we are taking effective rate of interest whole to the power N. So the principal is here 8,000. 1 plus 0.1698 over 8 years. So multiplying this value 8 times and then multiplied with 8,000, the amount will be 28,052. We need to calculate the compound interest. So compound interest is equal to amount minus principal, which is 28,052 minus 8,000. So that is equal to 20,052 in terms of rupees. So this is a compound interest. Next problem. Find the compound interest on 7,500 at 14% for 4.5 years while interest is calculated half yearly. So when I'm talking about half yearly, obviously we have effective rate of interest. So therefore, R is equal to 1 plus what is I year? 14%. So 0.14 divided by half yearly means in a years it is calculated twice. So therefore, Q value is 2. Minus 1. Now R is equal to 1.1449 minus 1. So therefore R is equal to 0.1449, or we can write it as 14.49%. Now we need to calculate the compound interest in this problem. So first let us calculate the amount. So amount principal 1 plus R whole to the power n. Now principal is 7,500. R is 0.1449 and number of year is 4 1 by 2, which can be written as 4.5. So here they can also be separated considering the power as 7,500 into 1.1449 whole to the power 4 into 1.1449 whole to the power half. Half is nothing but a square root, because 0.5 can be separated as 1 by 2. So we can also use this method, or we can use the log to take 4.5 as a whole number. That is, the index form will be converted into whole number. Then again, taking log and anti-log also, we can find the value. Now here, multiplying this 4 times, multiplying with 7,500, and here we'll take the square root of 1.1449. So evaluating this, we'll get the final amount as 13,788. Now we need the compound interest. So compound interest is equal to amount minus principal, which is equal to 13,788 minus 7,500. So that is equal to 6,288 in terms of rupees. So like this, we'll calculate the compound interest annually as well as with the help of effective rate of interest. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.